So how I walk through any Euclidean geometry problem is the following, right? So I use CCT, right? Remember we said we must use CCT. The first C is center, 3 theorems that are related to a center. Then the second one, cyclic quad, 3 theorems related to a cyclic quad. Then here 3 theorems related to a tangent. Okay, so that is what you just need to remember there. Now we're told that in this diagram W, E, G and V, F, H are tangents. If those are tangents, what this tells us that we should remember theorems that are related to a tangent. So I'm just gonna highlight them. There is a W, E, G is this one here. This is W, E, G. So if it is a tangent, already we can identify that here we have a chord, right? EK is a chord, good people, right? If we check, EK is a chord. So because it's a chord and then this thing is a tangent, there is a theorem that talks about tan chord. Okay, so the angle between those is gonna be equal to this one, right? So I like to use variables, so I'll call this one X, then I'll also call this one X there. Whereas E4, right, E4 is gonna be equal to I look at the chord is EJ, so I move from E and J to the circumference, and then I look at the angle that is formed. So this is the angle that is formed there, so those angles are equal. Okay, and then I have also what we also have VFH as a tangent, right? So if we show VFH as a tangent here, it will be this line here. So this is VFH. So guys, this angle here, right, this one, it is gonna be equal to this one. That's what we can see. And then this one here, this one, E4 is gonna be equal to E3. Okay, so that is it. That is the tan chord theorem there. Okay, so those are already the angles we can identify. Now you might be tempted to use tangents from the same point, since that it's also one of the theorems that is talking about tangents, but this is not a tangent, guys, so you can't say this line is equal to that because they are not both tangents. It's only VFH which is a tangent. If both of them were tangents, that would mean that this line was gonna be equal to that line. Okay, so yeah, so we know that. Okay, so what else we have exhausted all theorems about a tangent. Now they will never tell us that you have a cyclic quad, but now you must look at 4 points which are concyclic, meaning 4 points that are on the circumference. As you can see, those are the 4 points. So what does that tell us? That tells us that this angle here, let me use this as Y. This angle will be equal to this one here. Wait, so if this and that are equal, and remember F4 is equal to E3, so that means it's also Y here, means all of them are equal then. And then we have many of them, guys. We have X here, right? That means here it's also X. And then we have this one F3, which will also be equal to this one, which means, all of these things, they are linked together. And we know that EF, as we're given, is equal to EJ, which means this one and this one, they are equal. So what does it mean? It means the base angles should be equal. So it means this base angle here must be equal to F3. Okay, that's what you must understand there. So yeah, quite nice. I'm sure that with this information labeled on our diagram, there is a lot we can do. Okay, now the first question said that prove that EJF is equal to angle K2. So where is EJF? This is E, you go to J, E, J, EJF is the whole one. so sorry. So EJF is the whole angle. Now we need to prove that it's equal to K2. Where is K2? This is K2. Wait, so I need to prove that K2 is equal to this whole angle. But I can already see it, guys. You know where? Angithi F3 is equal to K2. Angles in the same segment. And then F3 is equal to EJF. Why? Because they are base angles, right? They're angles opposite equal sides. So therefore, you see, guys, without even solving this thing, we're already done with it. So let's just quickly write it down. So what we'll write there is that we know angle K2. So that is for number 1 there. Angle K2. Right. Angle K2 is equal to which angle? Angle F3 is equal to angle F3, guys. Those are angles in a same segment, okay? And then angle F3 is equal to EJF, okay? Angle F3 is equals to EJF. Reason being what? These are angles opposite equal sides, okay? So because of this, we can say therefore K2 and EJF are going to be equal because both are equal to F3. So you can just write it like this to say therefore EJF is equals to F3 is equals to K2 because both of them are equal to F3. Then you are done. How? Why was it 4 marks? Guys, marks in Euclid, they can just scare you for nothing. But these things are, quite easy. Number 2, we need to prove that K1 and K2 are equal. So where is K1? So this is K1 here. This is K1. We need to prove that this K1 is equal to K2. Right. Now, how can we do that? K1 and K2, how can we prove that they are equal? Well, guys, look at that. I think I forgot to include one of the properties of a cyclic quad. Do you remember that if you have a cyclic quad, it means the exterior angle is equal to the interior opposite. So wait a minute. That means angle K1, so now for number 2 there, we know that angle K1 will be equal to EJF. What is our reason? Exterior angle of a cyclic quad. So therefore that means K1 will be equal to K2 because both of them, they are equal to EJF. And can remember we said K2 was equal to EJF, and right now we're saying K1 is equal to EJF. That means K1 and K2 should be equal. Guys, very, very nice stuff. If you do not understand at any point, please tell me, guys, so we don't move quite fast. We're leaving others behind. Right. A last question. Prove that KLFV is a cyclic quad. KLFV. So let me just highlight KLFV. Okay, we need to prove that this thing here is a cyclic quad, KLFV, right? So for us to prove that, we can either prove that the opposite angles are supplementary, or we can prove that one of the exterior angle is equal to the interior opposite. Now, that means if we can prove that K2 is equals to this whole angle, we would have proved that this thing is a cyclic quad. You see, we would have proved that this thing is it's a cyclic quad. Or if we can prove that maybe L2 was equal to angle V. But hey, L2 and V, how can you relate those two? how can you relate those two? And then we can also prove that this and that they add up to 180, but because we don't have any angles, it's gonna be impossible for us to prove that those things they add up to 180. So our only best bet is to prove that one of the exterior angles is equal to the interior opposite, and most probably is to prove that K1, not K1 because it's not an exterior angle K1, but K2, right? We need to prove that K2 is equal to F1 plus F2. That is our task. Okay, that is our task there. So let's see, how can we do that, guys? Is there anyone who did it? Yeah. Talk to me, guys. Who did it, guys? You managed to get it? You just walk me through how you did it there, guys. Do you see it? Guys, do you see that this thing is quite easy? Check. I want you to see something. Look at E2, right? And then look at J2. What is happening with those two? They are equal, right? So we can write it. E2 is equals to angle J2. What is our reason? Remember, angles in a same segment, right? That is what we have. So if E2 is equal to J2, right? That is okay. Remember also a J1 is equals to F2. I want to call them X and Y, yes, but then you know what, it's fine. Let's say J1 is equals to F2 because those are also angles in the same segment. Angle J1 is equals to angle F2 because those are angles in a same segment. Okay, so if that was that is what we have, right? If that is what we have, that means we know that angle check J1 is equals to F2, E2 is equals to J2. Now remember, from previous stuff we already proved that K1 was equal to EJF, right? We already proved it. Remember that. So I'm gonna just put, we can use this symbol, guys, né? This symbol here is for sins. Okay, it says sins. It says sins. It's a mathematical symbol for sins. So since actually this one is but it's fine, you can still use it in the same way. So since K1 is equals to EJF, right? This was proved already, ne? And we know that K1 is equals to K2, right? So this tells us that K2 will be equal to, that means K2 will be equal to EJF. K2 and EJF are gonna be equal, right? So since K1 and K2 were equal, so what is EJF? Let's look at EJF. It's made up of J1 plus J2, isn't it? EJF is made up of J1 plus J2, right? That is what we had. So therefore, since J1 is the same as saying F2, I can say angle K2 is gonna be equal to angle F2. Instead of writing J1, I write F2. Then plus what? Remember, J2 is equal to E2, so I'm gonna write E2 there. You understand? If K2 is equals to F2 plus E2, that means we have just said that K2, which is this angle here, that is exterior angle, it's equal to this F1 plus F2 plus E2, oh yeah, that's what we said, but you just have to remember that E2 is equal to F1, or E2 is equal to F1 because of tan chord. Now I'm probably saying a lot. I don't like it when I'm saying a lot of things. So, but in a way, because E2 and F1 are just equal, that means angle K2 is equal to F1 plus F2. Okay? So in the ultimate end, I just wanted to prove that K2 was equal to F1 plus F2. And since I have proved that, that means that what is that? KLFV is a cyclic quad. Okay. Reason being what? Converse exterior angle of a cyclic quad. Please remember that if you are using other theorems to prove a theorem, you use the word converse. What? Converse. Okay, so are we happy with that? Any question? No question. Okay. Alright, so I hope it was clear, guys, ne? So we're gonna try and look at another one. So this is the next one, right? You are given a diagram. You just need to find the value of x. I'll give you a few minutes to try it out, and then we can work it out. So the first thing is that now we have a pair of parallel lines. So we do know that we can apply our proportionality theorem. Now we're looking for x, which is on the side VP. That becomes our want, and then this one becomes our given. And then we're going to match the want this side and the given that side. So that means we are to say that VP over PR would be equal to VT over TK. Our reason being line parallel to one side of a triangle. Now VP is 2x minus 10, and then PR is 9, VT is 4, and then we have 6. So we're gonna cross multiply there, have 2x minus 10 be multiplied by 6 and 9 be multiplied by 4. Now if you do a nice distribution there, you will have 12x. You will have 12x minus 60 being equal to 36. Now if you take 60 to the other side, you're going to have 12x being equal to 96. Then if you divide by 12 there, both sides, your x should be equal to 12, 24, 36, 48, 60, 60, 72, 84, 96. So it's 8. I hope it's correct. Guys, if you got it correct, if you got 8, please do raise your hand so that we can see. Next one, right? So this one is also quite beautiful. So just give it a try, okay? Give it a try there. Okay, so let's do corrections, right? We're given that in this diagram, EFGK is a cyclic quad. Now the moment they tell us that that is a cyclic quad, what is the first thing that we should do there? We should immediately check the angles in there. Yeah, it's EFGK. EFGK. Let me just highlight it, guys. EFGK. That is the one that is a cyclic quad. Okay, that's your cyclic quad there. And then that is where from there you can get your theorems. You should always remember theorems related now to a cyclic quad. The first thing we're gonna do there is to identify that the exterior angle of a cyclic quad is equal to the interior opposite. that actually means that here we got a 90 degrees, right? According to that. And then that means here it will also be a 90 degrees, since these are angles on a straight line. And remember, this angle and that K3, when you add them, you should get 360, you should get 180, because opposite angles of a cyclic quad are what are supplementary, they add up to 180. Now angle F is 90 degrees. EK and FG are produced to meet H, and that we have a line that is parallel. This one is parallel to that. So if they are parallel, guys, let's remember that we have U-shaped angles here, which are called co-interior. So this, when you add it to this one, you should get 180. That means this should be 90 degrees. Okay, that should be 90 degrees there. And let's also remember that this angle here, I'll put a star on it. Let me call it X. In fact, this one here would be equal to this one here. Why? Remember, those are your alternating angles. Those are alternating angles. Okay, guys, so let's look at what the questions are looking for. 3.1.1, it says, prove that JHF is 90 degrees. Now if we check JHF is this one here, right? So we need to prove that it's 90. Oh, guys, you can already see there, right? We already got the answer. So we can simply say JHF, which is just angle H, is the whole of angle H, but it's fine. Let's call it JHF, right? When we add it to angle F, which is this whole angle here, when you add it to that whole angle, what should you get? You should get 180 degrees, because those are co-interior angles. And remember to state parallel lines, which is EF is parallel to what? HJ is drawn parallel to FE. Yeah, FE is parallel to HJ. Now that means now JHF plus 90 degrees that is given, right, will be equal to 180 JHF. So therefore JHF will be equal to 90 degrees. Did we get it, guys? Let's see. Guys, we can't say angles are equal, then we say co-interior angles. When you talk about co-interior angles, you must show the plus sign. You must show the addition. You understand? You must show that you are adding them. Okay, so I hope it is clear that those are not they are not corresponding angles. They are co-interior because of the U shape that they are making there. When you add them, what is there? You get what? 180, and that's why we are saying this. So please, guys, please remember that. Okay, now next question, 3.1.2. It says prove that angle K2 is 90. It's gonna be quite easy, right? Because K2 is an exterior angle of the cyclic quad. Check, this is a side of the cyclic quad which is extended, so this exterior angle will be equal to the interior opposite. Okay, so that's what we're supposed to write there, that angle K2 is gonna be equal to angle F. Reason being that you can even say equals to 90 degrees, and then your reason is gonna be exterior angle of a cyclic quad. Exterior angle of a cyclic quad. Okay, I hope we got that one correct. Let's see. Guys, does turn chord work there? No, it can't work. Turn chord can't work, guys. Exterior angles, opposite angles of cyclic quad. Okay, I see some of you took it the longer way. Okay, I see, guys, right, what you are doing there. But then, guys, please, it's exterior angle then. If you want, you can also say that this and that they should give you 180, then you say opposite angles of a cyclic quad, then you get this one using angles on a straight line. You get K2 using angles on a straight line. It's still okay. Many ways of doing it there. Right, and then now it says 3.1.3, prove that HKG is similar to JHG, right? So let's just highlight those two triangles. First triangle is HKG, right? And which one? And JHG, okay, those are our two triangles. First thing is first, guys, this is a common angle here, because this angle G1, it is in both triangles. Okay, so actually we have to start there to say angle G1 is common. Okay, angle G1 is common because G1, it is there in the bigger blue triangle, it is also there in that brown triangle. So guys, in similarity, once you have one angle, you just need one more angle, then you will be done. So you can see that in JHG there is a 90 degrees, so we can simply say JHG is gonna be equal to angle K2, right? Angle K2, because both are equal to 90 degrees. Okay, both they are equal to 90 degrees. Then guys, we just look for the third angle. In the blue triangle, the angle that we have not spoken about is this one, while in the brown we have not talking about this one. So those, you just equate them. You tell them GJH will be equal to angle KHG. Then you just write the third angle. Please guys, you just say third angle. So because of this, therefore you rewrite their statement that triangle KHG is similar to triangle JHG. Then you just write angle. That's it, guys. So similarity is quite easy because you just need, all you need is two pairs of angles that are equal. And if you have a common angle, you should just be happy. Okay, so last question there said calculate JH and KG if that and that is that. So guys, these questions that usually come after proving similarity, they need you to use the information from similarity. So what you do here, you tell them that you make a frog, like I told you before. You're gonna make a frog here like this. So then what are you gonna say? You're gonna say HK over JH will be equal to KG over HG will be equal to HG. Oh, I think I made a mistake. Oh yeah, HG over JG. I made a mistake there. It's HKG JHG. It's HK over JH. It's KG over HG. Then it's HG again. Yeah, over JG. The naming here is something else. JG. So you tell them that this, you are taking it from similarity. Okay, then from there, guys, remember, you're just gonna match. There's JG, you circle it there. There's KG, you circle it there. HG, you circle it there. JH, you circle it there. Okay, so the ones with most information, so they want JG and KG. So let's start with these two because they are matching there. But okay, actually let's substitute what we have. Do we have HK? We're not given HK. Do we have JH? We are given that is 10 centimeters. Do we have KG? We don't have. Do we have HG? We are given that is 5 centimeters. Do we have HG? We're given that is 5 centimeters. Do we have JG? We don't have. So guys, I believe from this you can see that here we can try to use which one are we gonna use? Let's try to label them. So let's label HG as 5, and then let's label JH as 10. So do you see that we can find JG? Ne? We can find JG because that is a right angled triangle. So we can simply use Pythagoras there. Ne? Yeah, quite nice. So we can say JG squared is equals to JH squared plus HG squared. We say Pythagoras. Courtesy of Miss Simi, very, very good, ma'am. Very beautiful solution there. So you have JG squared is equals to JH is gonna be 10, right, squared, and then HG is gonna be 5 squared. Then using your calculator there, you can find the answer there, which is the square root of 10 squared plus 5 squared. So it's gonna be 5 root 5 centimeters. Wow, very good, guys. So that is JG here. So we put JG. Now we know JG here. Yeah, very good. 5 root 5 centimeters. So now from this, now that we have this one as full, we can actually use it to find kg. We can use it to find kg. So we can simply say kg will be equal to 5 over 5 root 5 multiplied by 5 centimeters. We just multiply by 5 both sides. So if you do that, you're gonna have your answer as, so what is 5 root 5? 5 over root 5. It's just root 5. What? 5 over root 5 is simply root 5. How does that one work? Oh yeah, simply root 5. Okay, so the answer is simply root 5. Let me see if the other people got it here. Nothing here. Nothing here. Nothing here. Guys. Miss Londolan, what's going on? Nothing here. Miss Latita. Very good, Miss Latita there. I see you got it. Very good. But you were not done. Yeah. Okay. So, very good. If I were to ask you a question, I would say, prove that triangle JHG is similar to triangle EFH. Now that one will be a beautiful question. That one will be a beautiful question. You see, the one that's gonna need you to think. Yeah. The one that's gonna need you to think. Yeah? No, not EFH. Did I? EFH. Okay, yeah. It will be a bit difficult. Yeah, it will be a bit difficult. Unless if we were to say EJH, if we were to say EJH, but now we would need to get a 90 degrees here somehow, and we are not sure it will be 90 there, So yeah, I do see why they didn't ask that one. But guys, as long as we have two pairs of angles that are equal, we can then just conclude to say the third one is gonna be third angle. But you know what? I want to give you one last chance, guys, to prove yourselves. I know that you guys are very brilliant. You know what? Let's do this other one, the last one on Euclid. Right, so here's a question, another question, guys. Prove that, give a reason why D3 is 90 degrees, give a reason why this is a cyclic quad, give a reason why D2 is X. You are just giving me reasons here. Then here you prove that these are equal, then you prove that these are similar. Right. So because these are quite simple, we'll just give you 10 minutes to work on this. So the first thing you want to do in this question there, right, is to make sure that you list all the information given. So the instructions say that BC is a diameter. Guys, if it says BC is a diameter, that means you should remember angles related to a center, theorems related to a center, and also we should remember angle in a semicircle. So since BC is a diameter, so we can tell that here it's gonna be a 90 degree. And then what else? Yeah, that's it there. Then we know they're told that there is a tangent at point D there, so it's AD. So since it's a tangent, that means this angle, if I call it X, it will be equal to this one, X. So when I get D2 and that, both will be X. Okay. What else there? Yeah, that's it. And then yeah, EA is perpendicular to AC. All right. And one thing we should understand, guys, about having a 90 degrees and X is that here it's gonna be 90 degrees minus X. That's what you must know, that here it's gonna be 90 minus X, and in the bigger triangle here it's also gonna be 90 minus X in that bigger triangle. So that's one of the things we must understand there. So give a reason why angle D3 is 90 degrees. I believe we can see that is because this is an angle in a semicircle. Okay. And then why is ABDE a cyclic quad? ABDE, why is it a cyclic quad? Because D3 is equal to that one, you see. So you tell them that D3 is equals to angle A, the whole of angle A. Reason being that both of them are equal to 90 degrees. That is we can say proved, because we proved that angle D3 was 90. So therefore this is a cyclic quad. Reason being that the exterior angle is equal to the interior opposite. Right, that is for this. Or you can say converse exterior angle of a cyclic quad. Okay, so you can either use converse, or you can tell them that the exterior angle is equal to the interior opposite, since both of them are equal to 90. Okay, so because of that, it makes ABDE a cyclic quad. If you wrote exterior angle of a cyclic quad, it's wrong. Okay, it's wrong. It's not, you don't use the theorem, but you use the converse. We don't use the theorem, but we use the converse because we're trying to prove it. Okay, so yes, indeed, if you also said opposite angles of a cyclic quad, but you must have written it like this: opposite angles of a cyclic quad, they add up to 180. So if you wrote this, that will be the correct reason. Or you can write converse. You can write converse opposite angles of a cyclic quad. Guys, we must write cyclic quad, and just write in CQ because of time. Now D2 and X. So here we do know that it's also a 90, right? Yeah. So D2, why is it equal to X? D2, why is it equal to X? Tan chord theorem, ne? This one we use tan chord theorem. So most of you wrote that. That is very good. Right. Then now for 2.2a, we needed to prove that AD was equal to AE. Quite an interesting question there. So how do you prove that AD is equals to AE? Let's look at them. This is AE here, and then this is AD. To prove that they are equal, you need to prove that this angle is equal to D1. You see, you need to prove that it's equal to D1, meaning you need to prove that D1 is 90 degrees minus X. That's what you need to prove. Now, quite interesting. How can we prove that? Well, I don't think it's going to be quite difficult, because why is it 5 marks? Even I don't understand why they're giving it 5 marks. Okay guys, so what you simply do is that you tell them that EDB, right, plus angle D3 will give you 180 degrees. Why? Because these are angles on a straight line. Angles on a straight line. So that will mean that EDB plus the 90 degrees, because we're already given an angle for D3. So it means EDB will be equal to 90 degrees. Then you tell them, right? You tell them that EDB, since it's 90, which means we're saying this one, since it's 90 degrees, it's made up of a certain angles. It's made up of D1 plus D2. Okay, so both will make 90. But we already, from 2.1 letter C, we already said D2 was X. So we'll say D1 plus X is equals to 90 degrees. So therefore, angle D1 will be 90 degrees minus X. Please guys, do you see that it helps that whenever you have a 90 degrees, and if you know that this is X, the remaining angle, you should call it 90 minus X, just as we did on that bigger triangle. Since this was 90 degrees and then there was X, the remaining angle will be 90 minus X. So it helps you to see that it's possible to prove that that D1 is equal to angle E, because right now we have proved that D1 is 90 minus X. Do you see that? We have proved that D1 is 90 minus X. So we know that here it's 90 minus X. All that is left is for us to prove that angle E is 90 minus X, which shouldn't be difficult, because if we look at in triangle EAC, we just tell them that angle E plus angle C plus angle A should give us 180 degrees, reason being sum of angles in a triangle. So angle E we do not know, but angle C we know that it's X. Angle A we know that it's 90 degrees is equals to 180. So therefore angle E will be 90 degrees minus X. So because of this, therefore angle E is equals to angle D1. Since both is equals to 90 minus X, then we say therefore AE will be equal to AD. Reason being, these are the sides that are opposite equal angles. Okay, those are the sides that are opposite equal angles, and that is the reason that we use. Now let's go to the last one. So now we know that this one and that are equal. We know that those are equal. Now we need to prove that a triangle, we need to prove that triangle ADB. So I'm just gonna try and highlight that, but okay, let's try to highlight triangle ADB. This one, and then the other one is ACD, which is ACD. The moment it's saying AA there, you must check that angle at A. And what do you know? It turns out that that angle is common for both, because that A2 is in the red triangle, it's also in the green triangle. So you can already start there, that angle A2 is common. Now if angle A2 is common, we just left with finding one other angle that is equal. Which one will be that? The one that is in a red triangle and then the green triangle. Yes, it's D2. We already know that D2 in the red is equal to the one in angle C in the green. So we say angle D2 is equal to angle C, since both are x. We already proved this before. Then the remaining angle in the red triangle is B2. And then the one in the green triangle that we have not talked about. We talked about A2, we talked about C, we have not talked about ADC. So we simply say ADC, then we just say third angle. You see, that's how similarity is so easy, guys. We are done. Therefore, just say triangle ADB is similar to triangle ACD, angle. Beautiful. Then you are done. So guys, I hope you see the importance of the following things. These are my take home on Euclid. Up to so far, I've really tried my best to ensure that you know how to apply these theorems. So all that is left is up to you guys. Number one, I'm hoping that you have seen how I use CCT to answer questions before I even go to them. Meaning I have to remember 3 theorems related to a center, 3 theorems related to a cyclic quad, 3 theorems related to a tangent. How will I know I have a center? The keywords will be center, right? The keywords will be diameter. These will remind me of the 3 theorems. You can recite those theorems. You know, angle at the center is twice the one at circumference. Angle in a semicircle, line from center perpendicular to a chord bisects the chord. And then for cyclic quad, you just have to check 4 points that are on the circumference. That tells you that you have a cyclic quad. Exterior angle of a cyclic quad, opposite angles of a cyclic quad, and then angles in the same segment. Now tangent, they will tell you tangent, that there you have a tangent. 3 theorems, tangents from the same point. If you have 2 tangents, then tan perpendicular to radius, and then tan chord theorem. Those are your 9 theorems, guys. So you just have to make sure that you label as much information as you can on your diagram to already assist you to answer questions before starting. And then lastly, the proportionality theorem. If you can remember the proportionality theorem, please just remember want over given, and then matching there. Okay, and then also remember areas. In terms of proportionality theorem, remember areas, that we have this triangle that is like this, whereby if I form any triangle, as long as it's from the apex to the base here, all of these triangles are going to have the same height. Okay, all of the triangles inside are going to have the same height. That will help me with questions that are asking about area. And let's remember triangles that are going to have a common angle, that those triangles you can you can calculate the areas using the area rule. Okay, you can use the area rule. You can always go back to our previous video on that to just remind yourself. And then lastly, for similarity, what do you do for similarity? All you need to do for similarity is to check whether you don't have a common angle, right? Just check to see if you don't have a common angle, or just an angle that is equal in both triangles. Angle that is equal in both triangles. If you can find that angle and then another angle, you just need 2 pairs. Okay, you just need 2 pairs, and then you will have done proving similarity. So those, good people, those methods that I gave you there, trust me, keep on practicing them. Every day you do a Euclid problem, every day you do a Euclid problem, and you are more than welcome to send to me that problem you did, and then just practice every day, so that in Euclid you're okay, because I told you this is around 50 marks in your paper too, so you need to make sure that you keep on doing that. Now, apart from these, there are proofs of the theorems. You need to prove 5 theorems in grade 12. Now, that is something that I'm not going to be able to have time to do with you guys, but I sent you the link to you can just go there and watch the method that I use, because my method is a bit different from the one that is used at school, right? So please just go watch that one. If you do not understand it at any point, you just tell me, and then we can see if we can arrange to do it, okay? But otherwise, this is the end of Euclid from me. I hope that it has been a nice journey and I hope that we learned a lot, okay? So the next thing we're gonna go to now, we're gonna go to finance and probability, okay? We're gonna go to finance and probability. Hopefully we're gonna start that next week. We're gonna start that next week, okay? Yeah, unless if the schedule says otherwise. I think it's a Wednesday today, ne? If there is a Friday, if there is maths on Friday, then it means we'll start it on Friday. Just forgot the schedule. No, we don't have, but then it's fine. We'll start it next week there. So please keep practicing, guys. And yeah, that is it for me.